So today we are going to look at this kind of a question. It seems to be difficult. This is a trig function, finding a trig function limit. So the limit as t approaches 0, we are given the sign of 3t and the sign of 8t. But before we continue, I want you to recall this function. As the limit of theta approaches 0, we are saying sine theta over theta is equal to 1. So this is the rule that we are going to apply here, because it is a trigonometric function that is used to evaluate the limits. So that is to say, we are given this function, that is as the limit of t approaches 0. I want to separate this. It's the sine of 3t, that is over 1, multiplied by 1 over sine 8t. So which is just the same thing, right? Then the second thing, I want to introduce a t in these two parts. There must be a t here, there must be a t here. That is to say, introducing a t, it will be the limit at t approaches 0. We are given a sine of 3t over 1 multiplied by 1 over sine 8t. Alright, introducing a t, we just take a t over a t, which is the same as a 1, right? The first t, I take it here, then the one that is in denominator, I bring it here, so that the limit as t approaches 0 will be left as the sine of 3t over a t, and then we multiply by this one, I bring it here, it will be a t over sine 8t. Alright, this is just the same thing. After that, then I do manipulation. The other thing that is remaining, this one and this one. So I can separate these two limits into two ways. The limit as t approaches 0, I may say the sine of 3t over t, then we multiply by the limit as t approaches 0, the t over sine 8t. So remember, for this one, we are just going to multiply by a 3 over 3, so that to bring a 3 here, so that this one will be the same as this one. But for this one, we have to take the reciprocal part of this by taking 1 over sine, so that we bring sine 8t into a numerator to behave like this function. So that is to say, as the limit of t approaches 0, we are going to say the sine 3t over t, and then this here, I say we multiply by a 3 over 3. So multiply by the limit for this other one, limit as t approaches 0, we are going to take a 1 over this other function, we bring it in the denominator. And then after that, to bring this 8 here, we multiply by 8 over 8. We are placing 1 over a reciprocal of that function, because we want the sign of a function to be on numerator, not on denominator. So if it will be in denominator, it will not qualify our condition, which is this one. So that is to say, as the limit of t approaches 0, we are saying this one will be a 3 sine 3t over 3t, and then we multiply by this one will be a limit of 1 as t approaches 0, 1 over 8 sine 8t over 8t. I bring it here, this one here, which is the same as 8t. Now we apply this use of change of variable technique. This one will be theta, this one will be theta. The approaches theta will be approaching 0, so we do the same. That one will be, so first thing before I do that, I want to factorize 3 outside, so that you left with the limit as t approaches 0, you left as the sine of 3t over 3t, and then multiply by 1 over 8, I bring it outside, I will left as the limit as t approaches 0, 1 over sine 8t over 8t. So after that, now we apply the rule. Applying the rule means that all of this function will be the same as this one. When you use the change of variable technique, you introduce theta here. Okay, let us do it. The limit as theta approaches 0, you will be having the sine of theta over theta, whereby I have defined theta at 3t, theta at 3t. Then when you try to evaluate the limit, theta will be the same as 0, which is more correct. Then we multiply by 1 over 8, the same as the limit of theta approaches 0, we will let at 1 over sine of, in this case we define also theta in two ways, as 3t, that is the first one. The second one, we will define theta as 8t, will be the sine of theta over theta. So that is 3 multiplied by a 1, and then multiply by 1 over 8. We multiply by 1 divided by a 1, you will get a 1. So automatically this will give us a 3 over 8, which is our limit. Thank you for watching.